So it's with great pleasure that we welcome David to address us this afternoon. So please welcome David.
Thanks, Don. This will be a bit of a test for you as well as for me, because you'll have to actually not drift off into PowerPoint soporific, dreamland. But I'm going to have to sort of describe things as we go, and you'll have to do your best to imagine things. So the people in the regions can see it because they're connected by Scott. Apparently the slides are getting through to them, but not to you. So I wonder if we can turn that off actually, rather than have a blue block in front of us. All right. So as Don described, this is work that's been funded by the the CRC for Water Sensitive Cities. It's work jointly done between UWA and an economics group at Monash University in Melbourne. And I'm going to be giving you a bit of an outline of some key results, so a selection of results from 2013 to 2016. So it's a selective presentation. It'll probably be even more selective now that I'll probably have to go a bit slower to describe it. So by way of background, investment in water-sensitive urban design or green infrastructure or water conservation measures is one of the things that the CRC is focused on, and it depends on a range of different types of benefits, which you might loosely categorise into monetary or financial or market benefits, priced benefits on the one hand, which are relatively easy to identify and measure, and then the more intangible, unpriced, non-monetary, non-market type benefits, and they're obviously more difficult to quantify. And because of a relative lack of information in that area, that's where the main focus of the work in this first phase of the CRC has been. There'll be some changes in the second phase, but much of the work that I'll talk about now is focusing on this issue of how do we identify and quantify the benefits of green infrastructure, water-sensitive urban design, the more intangible ones, and how can we find ways of expressing those benefits in monetary terms. So economists have developed a range of methods for doing that, and we've been employing mainly a couple of those methods in the CRC. So why do we want to do this? Well, because in trying to justify, make a business case for investments in these areas, there are certain cases where the more direct monetary, obvious financial benefits of the investment aren't enough to justify the costs. And so we're looking to see whether bringing in these additional non-market, I'll usually call them non-market benefits, but think intangible. If we bring those in, will that be sufficient to get the investment to appear to be attractive enough to be worth the investment? And so basically one of the main aims of this first phase of our work has been to try and develop a bit of a portfolio of analyses that have quantified these intangible benefits in monetary terms. Now all of the studies that I'll present in this area have used one of two different methods. One method is based on the way that particularly environmental or sort of aesthetic benefits can be captured in the prices of houses. So the house price depends on a range of different factors: how many rooms it's got, where it's located, how many bathrooms and so on. But one of the things that affects house prices is its location in proximity to environmental assets. And so in some cases we've been able to identify benefits resulting from green infrastructure that have been captured into house prices. So we observe many house sales, get the data for their prices and all the other characteristics of the houses, apply a multiple regressions, a statistical model to try and tease that apart and identify the bits that we're interested in. So what that does, none of these methods will capture every type of intangible benefit. What this does is it captures those relatively intangible benefits that matter to the homeowners, to the people who are purchasing these houses. So they're the local residents, basically, getting some benefits, and they can be captured in these house prices. We're not capturing some of the broader ecological benefits that might arise. and we're probably not capturing things like downstream impacts on flood risk, right? Because those people aren't actually participating in the market for these houses. All right, so we've got a few examples of studies where we've done this. The first that I'll mention is a study we did looking at conversion of a drain in Bannister Creek to what was called a living stream. So basically, when I actually lived just across the Canning River from where this was done in my youth, and when I moved in there in 1966, this was a pristine, well, I don't know about pristine, it was surrounded by agricultural land, but the waterway was still in pretty good nick, the stream. By 2000, it had been converted into basically a straight line drain, and a decision was made to convert it back to some degree to a more natural state. And from 2000 on, there was a period, there's some wonderful pictures here that you can't see, of the process of conversion of this drain. Initially it was made wiggly, and then there was a process of re-establishing vegetation, and so by 2010 it looks pretty similar, broadly similar, at least from a superficial level, to the way it looked back in 1965. And so what we were able to do was obtain data for single family homes sold in this part of Perth between 1990 and 2013. So we've got some from before and some from during and some after. We've got some housing sales in the area where this was occurring and some in neighbouring areas where it wasn't occurring. So we had about 16,000 sales, house sales. About 5,000 of those were sold more than once. 5,000 homes were sold more than once in that set. And there were 340 sales within 200 metres of this restoration site, and about half of those were after the restoration occurred. So we've got pretty good numbers of sales to do some statistics on, and as well as information about whether or not you're close to the restoration site. We've got data about land area, number of bedrooms, number of bathrooms, number of car spaces, brick and tile construction, whether there's a pool, which suburb you're in, age of the house, the year that the house was sold, the quarter within the year that the house was sold. So pretty much everything you can think of that might affect the sale price. And one of the pieces of data is the proximity to the restoration site. Okay, so I'm not going to walk you through all of the details of the statistics. It's a pretty elaborate and complicated process, but just to jump to the results, in this case we found some really interesting and favourable results. So we found that houses that were within 200 metres of the site eventually, after a transition period, resulted in increases in home values of between 4.5%. Quite big money. It's like $18,000 for the house sale. So it's a really significant benefit that householders felt that they were getting by living close to this site and were willing to pay to get. They could have chosen to live somewhere else. They chose to live here and pay a bit extra to get it. And if you compare those benefits, the aggregate benefits across the whole affected area, compared to the cost of the restoration, that also come out quite favourable. So the ratio of benefits to costs range, depending on how we did the sums and what sort of assumptions we made, they varied from about 1.5 to about 4. Okay? So we didn't have a scenario where the benefits weren't enough to outweigh the costs. And in most cases, they outweighed the costs by quite a lot. One interesting facet of this study was the way that the thing played out over time. So the initial result, for the first few years after the restoration process started, when you can imagine that there was earthworks going on, it actually looked worse to start with. House prices went down. Okay, so and then they went down by about as much as they eventually went up. Right, so for the first 3 years or so, things looked worse. Then they sort of got back to where they were, and after about 6 or 7 years, people were into a positive territory. And after 10 years, we were up to this quite large gains. All right, so that's one example. Another example of a study that we've done is looking in a similar area, and we were looking at evaluation of different garden types. So again, house price sales, house sale prices, and looking at high water using or high water conserving garden types. So is a native garden, how do houses go in the market if they have a very native water conserving garden compared to lots of green lawns and European flowers? Right? And so what we found in this case was that there was a win-win for the environment and for householders from some relatively modest level of conversion. So if you started with very European high water using garden and did a modest conversion, maybe 25% of it, into a more native type garden, there was a win-win. The house prices went up, but that if you went to 100%, then you were worse off. Right? So there was this sort of transition. People still like to have a bit of sort of traditional green European style on average. So obviously some people don't, but on average in the market, people like to retain a bit of the European style look. Another study we did was looking specifically at one particular narrow aspect of this issue, and that's around water tanks, rainwater tanks. So initially, the first thing we did was look at the value for rainwater tanks in terms of water conservation. Now, what's the water worth that gets captured and used in an urban water tank? And on that basis alone, the results were not very favourable. So we estimated that an average of a range of scenarios, the benefits from installing a rainwater tank amounted to about $650 over 15 years, depending on the size of the tank and various assumptions. And the cost was significantly above that. We're talking probably a couple of $1,000s, maybe more. However, when we did the house price analysis, we found that the benefits were substantially larger. And in fact, again, up, $15,000 or more improvement in house prices where there was a rainwater tank installed versus not. So we were really surprised at this apparent dichotomy between the water saving and the actual impact on house prices. We tested it in multiple different ways. We did multiple different types of statistics to see if this was a robust finding. We couldn't break it. We just kept getting this result no matter how we looked at it. So it seems to be very robust. So what's going on? Well, obviously people are valuing something other than just the water. There's some sort of, good feel-good effect, it seems to be, is being factored in here as well. So people, I guess it's indicating that people aren't necessarily doing very precise analyses or calculations when they think what they're willing to pay for a house. They're actually doing it in a more rule of thumb sort of way, perhaps a more heuristic approach. And so that was an interesting result. Okay, I think I've got one more of these examples that's on house prices, and that was looking at street trees. So just basically green space, green vegetation in urban areas. What effect does that have? So you can get you can see from that first example that it's likely to be a positive effect, and indeed we found that. This was looking particularly at trees, large trees in urban areas, and we had in this case 5,500 data points between 2009, in 2009 in Perth, and looking specifically at large trees. And again, we got a bit of an interesting dichotomy. We found that a large tree, such as a large tree with a covering an area of about 16, 20, 30 square metres, so it's a significant sized tree, could add about $14,000 to the price of a house. However, that's specifically if it's on the verge. We found that if it's on the landholder's own property, it actually reduced the house price by about $6,000. Or if it's on the neighbour's property right up against the fence, it actually reduced. So I imagine people are concerned about storm damage or something like that from having large trees too close to the house. All right. I need to check my timing here because it's all shot to pieces with the late start. Okay. So now I'm going to give some examples of a different approach to try and estimate these non-market values, and that's around a survey-based approach. So it's more getting more at people's perceptions and feelings and what they will report rather than observing their actual behaviour. The advantage of the approach that I've just shown you is that there's no arguing about whether people are prepared to do it because they have done it, right? they actually have paid more for houses that have these characteristics. Whereas with the survey approach, it's well developed and it's reasonably robust, but there's always the question around, well, would people really do this? Because it's based on hypothetical questions about what you would be prepared to do. Okay, so these are surveys of the general public, not just people living close to the specific asset, so that's another advantage. It's a broader set of people whose attitudes have been captured. And the approach that we've used is a thing called choice experiments. There's a number of survey approaches that are used. This is the particular one that we've relied on most. And what we do is we put a range of hypothetical scenarios to people about choices that they would make, and then from the choices that they say that they would make, again we apply statistical models, and from that we can infer the trade-offs that they are prepared to make between the different options that we put in front of them. And one of the options that we put in front of them is a cost. So we can infer the relationship between the benefits they think they're getting and the costs that they're prepared to pay. We tease that out using statistics. So one of the advantages of this approach, another advantage is, I said that it captures a broader population. Another is that it allows us to capture a different type of benefits, as well as capturing the benefits that we were getting from the previous approach, which people feel because they're living close to it. They can actually use it, they can look at it, they might use it for recreation. In this case, we're capturing a broader category of benefits, which we call non-use benefits. So many surveys have shown that people place value on things that we have no personal interaction with, and sometimes even no personal experience of. So for example, protecting conservation of whales, right? We don't actually deal with whales, but many of us are prepared to say that we think that's an important thing to do. Okay, so that's a non-use, non-market value. Okay, so that's one advantage. The disadvantage is that it's hypothetical, as I said. Another disadvantage is that it relies on people's understanding of the issues. So if you're asking them questions about issues that they have no personal experience in, you would have less confidence in the answers that they give. If you're asking really deep questions about the ecology, for example, rather than about your use of this for recreation, it might be harder for people to give really good answers. Okay, so I've got a few examples in this area as well. One is a study that we did with the Swan River Trust, looking at a range of ecological related benefits from protection of the Swan River. And so, for example, so these are benefits per household per year. Sorry, per person per year. And 3 different types of benefits were listed. One was about maintaining the foreshore vegetation in good condition. And so we estimated a benefit there of $130 to $170 per person per year. That was the largest of the 3 benefits that we estimated. Another was trying to find a way of getting a relatively tangible way of thinking about the ecological condition of the water body itself. And so we did that in a couple of ways. One was about the average frequency of fish kills in the river. And so we were reducing the frequency. And so with the 2 scenarios that we had for that higher frequency and a lower frequency, we got a benefit, a willingness to pay of about $55 per head per year. So lower. And the other one was the health of the dolphin population. So there's only a small population of dolphins, sort of a couple of dozen dolphins in the river. But we put a scenario where we had an improvement in the average health and a reduction in the number of sick dolphins. And that generated a benefit of $55 to $110 per head per year. So that was interesting because that was talking about changes to a really small number of biological organisms, but it was really large. You aggregate those numbers across the Perth population, that's a huge benefit for 10 or something dolphins being made less unhealthy. So it shows that an iconic, I guess it highlights what you may anticipate, that particularly iconic types of benefits, like the dolphin population, are very highly valued by the community. My Monash colleagues did a study of this type, a survey-based study, looking at a range of different types of water-related benefits for Melbourne and Sydney. This is not Perth, just Melbourne and Sydney. They looked at improvements in stream health, Similar sorts of numbers to what we were finding for Perth, $160 per head per year, with a bit of a range, plus or minus 70. Reductions in water restrictions. This was done at a time, or soon after, Melbourne in particular had pretty significant water restrictions. So there was a willingness to pay to avoid those water restrictions of about $150 a year. And then cooler summer temperatures. So one of the benefits that we like to talk about in the CRC is the fact that if you get enough vegetation into an urban area, you'll experience a reduction of a degree or two in ambient temperatures. And so in Sydney only, they found a willingness to pay of about $50 per year. Not in Melbourne, interestingly. I don't know why not in Melbourne. It gets hot in Melbourne. I've been there when it's hot. Another one they found where there was no willingness to pay, or very low, was reduction in the frequency of urban flooding. So people didn't, at least in Melbourne and Sydney, they didn't feel that was a very substantial issue for them, which was interesting because the surveys were done not long after there'd been quite a significant flood in Melbourne, sort of a flash flood. Okay, another study of this type was one we did with the Water Corp, looking at the buffer zone around wastewater treatment plants. And so what we're looking at here is community preferences for different types of land use in the vicinity of a wastewater treatment plant. Assuming that there's going to be some sort of buffer, what would you prefer to be in the buffer? And so, just quickly to give you an idea of this one, we had commercial land use as sort of the baseline, and a few options relative to this commercial land use. So, local residents would be prepared to pay about $8 per head per year, per household per year in this case, for a 1% increase in natural vegetation, so conservation type uses in the buffer zone. So it doesn't sound like much, $8, but it's per percent. So if a 20%, 50%, it could add up to significant amounts. $4 per percent for recreational areas, and $1 per percent for agricultural, horticultural type uses. So all three were preferred to the commercial land uses. I guess that's not surprising, but there was a really clear-cut ranking of the preferences between commercial first, recreation second, agricultural, horticultural third. All right, that's not all of them, but that's sort of the examples I wanted to talk about for the studies that we've tried to sort of monetize these relatively intangible social, environmental, recreational type benefits. I want to briefly talk about another study that we've done now in Perth. This one's not quite complete yet. The guys that did this gave a seminar a couple of weeks ago, so some of you may possibly have been at that. This is about least cost strategies for reducing nitrogen and phosphorus pollution in the Canning River. Was anybody at that seminar with Syed and James and Maxine? No? Okay. So this is for the Canning. And I'm going to move relatively quickly through this so we have some time for questions. So what they've done in this study is not just identify the benefits of monetising the benefits of particular outcomes. They've tried to build a systems model that puts together the whole relationship between different management options or policy options. So they're saying we could educate community members and businesses, we could regulate them in various ways, we could build different types of infrastructure, we could apply soil amendment, we could do sewage infill, or we could put FOSLOC in the river. So quite a variety of different options, and what they're trying to do is identify which of those options in which specific locations in the catchment would be preferred, which would be the most cost-effective way of achieving particular pollution reduction targets. And so we're interested in the behaviour of the households in the Canning catchment. It's Canning upstream from about Rivet Bridge, I think. We're looking at recreational areas, we're looking at golf courses, and we're looking at some peri-urban sort of horticultural properties as well. And we're saying, okay, for those different parts of the catchment, which of these different management or policy strategies should we be applying? And so they have to identify what would be the impact of each of those options in each area on the level of nitrogen and phosphorus emissions reaching the river. Oh, and there's another option as well, which is sort of intercepting emissions through constructed wetlands or living stream type investments. And they're trying to, what they've done is they've quantified just the basic costs of implementing these policies and these physical activities, the cost to the individuals involved, but also the benefits, not just to the river itself, but the benefits also to householders, because some of the things that you could do, like constructed wetlands, as we've seen, have benefits back to the local residents. So they've captured that as well and built it into the model. All right, I hope I've conveyed the nature of this model. It's quite a complex model. It's spatial. We've captured each basically part of the canning catchment upriver from river to bridge. All right, so I can't show you the beautiful maps where we show how it unfolds as you go from 20% reductions to 40% reductions to 60% reductions, but basically that's what they've done. So we've got 10, 20, 30, 40 different levels of pursuing your target reductions. So the target reductions were a 41% reduction in nitrogen reaching the river and 30% reduction in phosphorus, and we looked at basically everything from 0 to 10 to 100% of reaching those targets. And what we find was that for the lower percentage reductions, the main strategies that are being used were around septic tank infill and relatively low cost behaviour change education type strategies. So going out and running community education, community engagement type processes. And a bit of use of slow release fertilisers on, I think that must be in public green spaces. Then as we go to higher percentages, it's tending to mainly focus on increasing the number of septic tank infills. But once you get to about 60% of the target, you start to get constructed wetlands coming in. Everything's starting to grow. The number of septic tank infills and the intensity of the behaviour change programs is increasing. The number of householders who are being engaged is increasing. The level of investment in education and engagement is increasing. And then eventually when we get up to about 90% of our target level, FOSLOT comes in and becomes the way you get from 80% to 90% in the river itself. All right, so this is one of the main casualty of the. I'm not having the slides, unfortunately. It's great. It would have been great to show those.
Do you want to put the monitor around?
No, I don't think we ought to do that. All right. So the basic result there was that the most cost-effective options were infill of septic tanks and slow-release fertilisers. And the priority areas were there's a couple of, within the broader catchment. There were a couple of the sub-catchments, which were Bannister Creek itself and Southern River, which were the ones that where most of the money was being spent. On the economic numbers, we could get 60% of the way towards the target reductions for about $300 million over the long term. That's like an aggregate over, think of it as a 20-25 year period. And that the benefits we estimate from that were about $440 million. Okay, so the benefits exceed the cost. Not massively, but enough to be worth doing. We found that we could not get to 100% of the target without going to one of the options which we judged to be relatively politically unpalatable, which was basically banning traditional type fertilisers. Any fertiliser applied in the catchment had to be slow release. So if we can do that, then we could get to 100% of the target, but at the cost of about 500 million. So, what you typically find in this type of study, I've done a number of them in different cases, that you can get to reasonable targets for not much cost, but as you get more and more ambitious, the cost starts to escalate. So to get from 80 to 100, you're really in a very steep part of the curve. All right. Another thing I wanted to just let you know about, one of the things that we're charged with doing is getting the word out and providing help and guidelines. Obviously, we're here today. But one of the things we've prepared is a booklet which has guidelines on ranking water-sensitive projects. So this is available on the CRC website. If you're interested in this, I encourage you to have a look. This is a particular area of interest of mine. I've helped a lot of agencies with ranking of projects and find that there's often some very simple things that they could do a lot better that would make a real difference to the quality of the ranking that gets done. So if you're involved in a project ranking process, I'd encourage you to have a look at this report, which is called Ranking Projects for Water Sensitive Cities, a Practical Guide. Ones that I'll cover over pretty quickly because I'd like to talk a little bit about the future. We've got a couple of student projects going on as well, at 3 at UWA. 2 of them are finished. One of them looked at the economic impact of groundwater allocation reductions in the north of Perth, and looking at the dollar impact. This was specifically focused on the dollar impact on horticulturalists from a hypothetical 25% reduction in water allocations. So this student found that it had 14 to 22% reductions in net returns, so a significant reduction in their profits. And then another student, a master's student, was looking at the most cost-effective way to maintain public open space with less water, and she looked at 6 different irrigation approaches and found significant differences in the cost per kilolitre of water saved between the different strategies. All right, I'm going to try and wrap up so we can have some questions and discussion. But before I do, I'll just give you a quick run through of where we're heading in this project. So just in the last week, the CRC has let us know that it's going to support a renewal or an extension of this project into another phase for another 3 years. This time the Monash crew has dropped out. They weren't interested in continuing, so the main group will be the UWA team, but with various other groups assisting us. So Nigel Tapper's group at Monash University, so Nigel works on urban heat island effect, will be part of the project. Some economic consultants from Victoria who've got good experience in this area. A South Australian consultant with his expertise is in stakeholder engagement. And we've got a really excellent project steering committee that will guide us through the project. And just very briefly, the sorts of outputs that we're trying to deliver this time. So in the first phase, as you saw, we had a pretty big focus on creating a collection of results for those non-financial intangible benefits. What we want to do this time is trying to create a system or a tool that helps people identify and estimate values that they can use for particular analyses. So that means interpolating, extrapolating from the existing evidence that we've got. So part of that will be about advice about whether there is an existing study that you could use that's close enough to your context, or whether there's not, in which case you're either stuck or you need to do an original study. And so we'll try and capture as many studies as we can in the area of to value benefits related to ecology, water quality, recreation, aesthetics and urban heat. The second output will be a comprehensive tool for benefit cost analysis of investments in water sensitive cities. So we'll try and, you heard me describe that process for the Canning River. We'll try and create a tool that allows you to do something like that in a relatively simple way. So this is a tool that will capture the non-market benefits, the market benefits, the biological and physical impacts of the changes that we make, behaviour change, risks and uncertainties in the system, time delays, time lags in the processes, and full life cycle costing of the different options. So we'll bring them together in an economically respectable way. And our aim is to do this in a way that allows users to use it in quite a flexible way, and for it to be scalable from relatively small scale projects up to quite large ones. The third output is around sort of program, it's about sort of policy and financial aspects. So advice on financial models and policy approaches to foster investment in water sensitive cities where the benefits are not necessarily captured by those who bear the costs. So a perennial problem, many types of programs, is that the benefits come are borne by one group and the costs are captured by another. What are our policy options and finance systems to deal with that? And then the fourth is a set of outputs, which is a set of case studies, where we'll try and test and adapt the various tools and approaches that we develop, but also deliver useful information about these specific case studies. And these case studies, we've got a set of case studies in the proposal that have sort of been more or less signed off on, but it's still a moving feast. We'll be developing and working with our steering committee on selecting additional case studies as we go forward. There'll be some in WA, some in Victoria, some in probably one in Queensland, although that's still unclear. And there'll be a wide variety of different things. So for